All right, good morning, guys. Welcome back. I'm going to pick you up again from where we were on Friday. Remember, we're looking at the Sierpinski triangle empty regions. The Sierpinski triangle is you take the original triangle and then you draw in the midpoints of, the mid segments of the triangle, and then you draw in the mid segments of the three triangles on the outside created and the mid segments on those. Etc. Now, the first question that came up, and I'm not going to go too far with this, but it's a great question, is why is the Sierpinski triangle the result of running the chaos game? We can prove that when you do the chaos game, you could only land on these segments, and that's in some sense mathematically why. But why a totally random event, totally random process would result in such a pattern is a great mathematical question, which probably we should leave for philosophy, but we'll hold off on it for now and talk about it again when we talk about fractals next week. For now, the question we want to ask is, if this triangle is empty, and these triangles are empty, and these triangles are empty, etc., 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 how much of the Sierpinski triangle is empty? That's the question we want to ask. And what we got to on Friday was that if you take the original triangle as having area 1, or 100% if you like, what we found was that the empty regions constitute 1/4 plus 3/16 plus 9/64 plus 27 2/56 plus 81 1,024 plus etc., etc., etc. of the original triangle. And the question is, how much is that? What does that add up to? Well, we could do some fractions here. Fractions are wonderful, right? This is 4/16 and this is 3/16. So these two alone make 7/16. This is 7/16, 9/64. So that's like 28/64 and 9/64. That makes 37/64. By the way, that's about 1/4. That's about 1/2. That's now a little over 1/2. 37/64 is, let's see, 420, 148 2/56. 148 2/56 and 27 2/56 is what? Maybe 175 256? I'm making that number up. Let's see. 120, 148, 168, yeah, 175. Add those two together, and we get, that's 350 plus 81 is 431 1,024. Obviously, I've done something wrong because that's over 1/2. 4 times 175 is 700. 781. Sorry, my mistake. 781. We're now well over 3/4. 3/4 of that would be about 750, 768. So this is more than 3/4 of the triangle is empty. Okay, that's kind of interesting, but what does it mean? What does it really add up to? How do you add infinitely many things? How do we take this infinite sum and make sense of it? How do we say, what does it add up to? Well, step one is to say, suppose this adds up to something. I'll call it S for sum, S-U-M. Now, I have to say, as a side note, that really isn't a side note, it's kind of crucial, is that just writing equals S is to say that this does in fact add up to something. So just writing this equals S asserts that this sentence makes sense, which is a non-trivial statement, but I'm going to make it anyway without proof. I now take this equation and I divide both sides by, no, I multiply both sides by 3/4. I multiply 3/4 on this side and 3/4 on this side. Now you should know why I picked 3/4. But if you don't, just play along with me. On the left-hand side, I get 3/4 s. On the right-hand side, I get 3/16 plus 9/64 plus 27 somethings. No, I wrote this down wrong. This is 9/64. See up here? So when I multiply it by 3/4, I get 27,256 plus, etc., etc., etc. Sorry about that, guys. Now what I'm going to do is focus on the purple. Look at the purple for the moment. S equals 1/4 blah, 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 blah. 3/4 S equals 3/16 plus blah, 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 blah. Ignore the black there. I simply put it in to multiply both sides of the equation by something. Now what I'm going to do is kind of in an old-fashioned Algebra 1 kind of way, take this equation and combine them. How am I going to combine them? I'm going to take this equation and subtract it from this equation. Again, don't focus on the 3/4, guys, just focus on the purple. What do I get? On the left-hand side, I get S minus 3/4 S. S minus 3/4 S. Remember, this is 1S. 1S minus 3/4 S leaves 1/4 S. That's algebra. On the right-hand side, something interesting happens. What happens is that this term and this term cancel each other out. This term and this term cancel each other out. This and this cancel, etc., etc. Now, take a moment and at least think about the fact that which list is longer, the one in this line or the one in this line? Well, I've taken this line and covered one up. So one might think, this list is shorter than this list. That is to say, this list is shorter than this list. That is to say, at some point in matching these up, this row is going to run out. When's it going to run out? It's going to run out when there aren't any of these left to give. When aren't there going to be any of these to give? There will never happen. So all those things cancel, and I'm just left with 1/4. Multiply both sides by 4 here, and I come out with S equals 1. Now there are some things here that are difficult. What's difficult? Algebra, subtracting. Are these lists the same length? Can we really do this subtraction? But the big deal here, guys, is look what this comes out to. S equals 1. That means the empty region is 100% of the original triangle. The Sierpinski triangle is completely empty. These empty regions occupy 100% of the original triangle. Now that's a startling result, and it's what you're going to find is fractals, which is what the Sierpinski triangle is, often give us these startling results. And we're going to have to wrap our brain around these things to the point that we come to expect the unexpected. But for now, what I want you to just think about is here's how to add up an infinite series. Because we're not talking about fractals at the moment. We'll come back to them next Tuesday. For now, I want you to think about infinite series. And I want to pose to you two of the more common infinite series that often provoke discussion or disagreement or what have you. One of them, which you've probably fought with other kids about, any self-respecting nerd got into a fight about this on the playground at some point, and that is 0.9 repeating. 0.9 repeating, I hope you know, equals 1. How to prove it? There are lots of different proofs. But one approach to 0.9 repeating is that it's an infinite geometric series, which is what we're talking about right now. It's 9/10ths plus 9/100ths plus 9/1000ths plus 9/10,000ths etc., etc., etc. Now, this series can be treated just like the one on the previous page from Sierpinski's triangle. We can set both sides to S, and then we can multiply both sides by 1/10. And I want you to proceed there. It's going to be hard. You may not get it the first time. We'll talk about the solution tomorrow. I want you to proceed there to try to show, by the algebra I did on the previous page, that S is 1. Another common geometric series that provokes fights is this one. Oh, you know this one. This one is the one where you say, let's start out going toward a door, and we go halfway to the door, and then we go half of the rest, and we go half of the rest, and we go half of the rest, etc. That's the infinite geometric series. It looks like 1/2 plus 1/4 plus 1/8 plus 1/16 plus etc., etc., etc. Set both sides equal to S. Sorry, set the right-hand side equal to S. Multiply both sides by 1/2. And off we go. Now this one also is going to add up to 1. But not all series like this are going to. So here's your homework. What I would like you to do is take a piece of paper and write this and try to do the algebra for that. And write this and try to do the algebra for that. And the algebra you're trying to imitate is my algebra from the Sierpinski triangle process. Do this process with these two series. Take a picture with your camera and send it to me. I'm going to create an assignment on Canvas, which will be send in a picture PDF to me, and I'll do it on SpeedGrader on my iPad and make comments the way I was doing with proofs beginning of the year. So this is going to be submit a picture of your math work to me as an assignment. Thanks. Have a great day. This is going to be tough. I get it, but don't worry. We'll go through it all tomorrow. Have a great day. Stay safe. Stay well. Stay home.